Here we go. Let's look at section 9.4, solving quadratic equations by completing the square, day 2. Okay, so our learning target for today, by the end of the video, you will be able to find and use the maximum and minimum values that we've looked at in the past. So remember, a quadratic looks like a parabola when you graph it. And we said that the vertex of the parabola is going to be a maximum, right? It's going to be the greatest value that the parabola can take when we're looking at a y value, right? When the parabola opens down, it's going to have a maximum. And then when we see that the vertex is the lowest point that the parabola will take, it's going to be a minimum. Okay, so let's take a look at an example where we're finding the minimum value. This is example 4 that lines up, matches example 4 in your textbook, so you can take a look in your textbook if you need additional resource. So here's our quadratic, y equals x squared plus 8x plus 5. So let me ask you, why is this a minimum value? Why will there be a minimum value for this quadratic? And hopefully you said because the quadratic is going to open up. And the reason we know that the quadratic opens up is because the leading coefficient here is positive. It's a positive 1. So when we have a positive leading coefficient, we know our parabola is going to open up, and therefore the vertex is a minimum. Okay, so if we can find our vertex, then we know that the y value of the vertex will actually be the minimum value. So currently, this quadratic is in standard form, ax squared plus bx plus c. If we can put this quadratic into vertex form, then we can find what the minimum value is. So remember vertex form. Vertex form is y equals a times the quantity of x minus h squared plus k. Okay, and then the vertex we said is h comma k, and our k, which is our y value for the vertex, will be the minimum or the maximum value depending on the direction of opening for your parabola. Okay. So our goal is to change this standard form quadratic to the vertex form. So here we go. First step, we're going to move the constant to the other side. And when we do that, we're left with y minus 5 is equal to x squared plus 8x. Now here on the right side, what our goal is to try to make this a perfect square trinomial, so that we can factor it to a squared quantity. So in order to do that, we're going to complete the square. So at this point, we're going to add our box on both sides. And to find out what goes in the box, we're going to take our b value and we're going to divide it by 2. And when we do that, we're left with 4. We're putting 4 in parentheses and squaring it, and we end up with 16. And 16 goes in the box. So to continue, let's simplify. So on the left-hand side, we have y plus 11 is equal to, now this is a perfect square trinomial, so we can factor that as x plus 4 quantity squared. Okay, and we're almost there. We almost have it in vertex form. So next we're going to subtract 11 on both sides. And we end up with y is equal to the quantity of x plus 4 squared minus 11. So then our vertex, we said, is h comma k. So what is the vertex then, looking at this vertex form for the parabola? And hopefully you said h is a negative 4, because remember the format is x minus h. So in order for this to be a minus, we know to change this to a plus sign, the 4 has to have a negative sign. Negative and a negative is going to give us that positive. So the h is -4 and our k is -11. Our minimum value is the y value, so we're just writing that number. So our minimum is equal to -11. Okay, let's look at an example where we're finding the maximum value for our parabola. So here's our parabola. We know it's going to be a maximum value because looking at this, our leading coefficient is negative. So we know the direction of opening for the parabola is down. So the vertex is here. And remember, we're finding that y coordinate for the vertex. That's going to be our maximum value. Okay, so let's proceed. We need to get this into vertex form. Right now it's in standard form. So as a reminder, our vertex form is y equals a times x minus h squared plus k. All right, so first step, like in the last problem, we're going to subtract the constant over to the other side. So in this case, we're left with y minus 2 is equal to -x squared plus 4x. Okay, so before we complete the square, notice we have a negative that's out in front of our quadratic term. So we need to factor out this negative because to complete the square, remember we said the leading coefficient has to be a +1. So we're factoring out the negative, and when we do that, we're left with x squared, and a positive divided by a negative gives us a negative. Now we're ready to complete the square. So we're going to add a box here. And since we're adding this box here, which is inside the parentheses, we're going to make this a perfect square trinomial here. But notice the minus that's out in the front. So really what we're doing is when we distribute this minus to each of the terms, we're subtracting the box. So instead of adding the box, on this side we're actually subtracting the box because that's what we did on this side. We added it, but if you distributed this negative, it's actually a subtraction of the box. So let's find out what goes in the box. So we're going to take our b term, -4, we're dividing it by 2, so we get a -2 in parentheses, and when we square that, we end up with a +4. So 4 goes in the box. All right, and now we're ready to simplify each side. So over on the left side, -2 and a -4 is a -6. Right? We still have a negative out in front of the parenthesis, and this now is a perfect square trinomial that factors to x minus 2. X minus 2 quantity squared. Getting this into vertex form, we're adding 6 on both sides. So we end up with y is equal to -x minus 2 squared plus 6. So looking at this, we know that our h, k, our vertex is going to be at a 2, 6. And since this is a maximum value, we know our y value of our ordered pair is our maximum value. So maximum equals 6.